Hi class, how are you today? Well, that was kind of mean. The learning target for today is to use geometric mean to find the missing measures of a triangle. Now, you may have heard of arithmetic mean, which is the average, but there's also something called geometric mean. So we're going to talk a little bit about that. For the scale, you're a 3 if you can use geometric mean to find the measures of a triangle. 2, you can find the missing measures of a triangle when the geometric mean is the altitude. That's the line that comes from the top of the triangle and hits the other side at a right angle. 1, you can find the missing measures of a triangle when x is not the geometric mean, which means you wouldn't have anything squared. And 0, you cannot find the missing measures of a triangle using geometric mean. Let's get started. So for the first example, we have find the geometric mean of 6 and 15. So when you deal with geometric mean, here's how you're going to set up every example. A over x equals x over b. So what you do with that is A and B are what are known as extremes. These are the numbers you're trying to find the geometric mean of. So in this case, 6 and 15 are your extremes. And then x is your geometric mean. So if you're going to set up this problem as a proportion, 6 and 15 are your extremes, and you're trying to find x. So you would say 6 over x equals x over 15. And then, just like every proportion that we've dealt with, cross multiply. X times x is x squared. And 6 times 15 is 90. And then now we want to solve for x. Here we have x squared, so we have to do the opposite of that, which is take the square root of both sides. So that'll leave you with x equals the square root of 90. Now the problem with that is we can simplify that, just like we did last class. So, square root of 90, to simplify that, remember, what's a perfect square you can take out of that? Well, it's actually right there, 9. So, x equals the square root of 9, and 90 divided by 9 is 10. So x equals square root of 9 is 3, and then square root of 10. So the geometric mean of 6 and 15 is 3 square root of 10. So in this case we have square root of 17 is the geometric mean, and 7 is one of the extremes. Find the other extreme. So again, we've got what we had before. A over x equals x over b. In this case, 7 is the a, and square root of 17 is the x. So we're going to say 7 over square root of 17 equals square root of 17 over b, and then solve for b. So cross multiply, 7 times b is 7b, And square root of 17 times square root of 17 is 17. The square roots cancel each other out when they multiply. Now, divide both sides by 7, and that will give you b equals 17 over 7. So the second extreme is 17 over 7, which if you want to turn into a decimal would be 8.5. So now why geometric mean is important in geometry. So there are two cases that geometric mean can be used in geometry, both of which deal with right triangles. So in this case, we've got a right triangle, P, Q, R, and we've dropped an altitude in the triangle. So with the geometric mean, we can find out different lengths in this triangle. So if you have a right triangle and you drop an altitude, different proportions get set up. So in the first case that it works, if you drop that altitude down, the two parts of the side that it separates become your extremes, your A and your B. And the altitude itself becomes your geometric mean, the x. So if I give you a triangle, and the triangle is A, B, C, and I drop an altitude to point D, and I say that BD is 3, and AD is 5, and I want you to find the measurement of the altitude. You would set up a proportion saying 5 over x equals x over 3. Cross multiply, and that would give you x squared equals 15. Take the square root of both sides, and you would get x equals the square root of 15, which can't be simplified at all, so that would be your answer. And you might also get cases where the side you need to solve for is one of the extremes and they actually give you the geometric mean, in which case you would learn what we just did in the last example and do it that way. Now for the second example that I mentioned. The second way that you can use geometric mean in right triangles is to find one of the measures of the triangle, one of the legs. So, in a right triangle, as you should know, there are 3 parts, 2 legs, the parts that touch the right triangle, and the hypotenuse, the one opposite the right angle. So, in this case, the geometric mean is the leg. So if you're trying to find for one of the legs, x, then the extremes will be the part of the hypotenuse cut by the altitude that is connected to the leg. So this would be your A. And the other extreme would be the entire hypotenuse. That would be your B. So in this case, what's going to happen is we want to find the leg AC, and we're given the 2 parts of the hypotenuse, 5 and 4. So first, you have to set up the proportion The geometric mean is x, the lead. One of the extremes is the part of the hypotenuse that connects to the lead. That in this case would be 5. And the other extreme is the entire hypotenuse. That's this whole length here, which would be 5 plus 4, which is 9. Now we cross multiply. 5 times 9 is 45, so we have x squared equals 45. Take the square root of both sides. And that gives us x equals the square root of 45, but that can be reduced. We can take a 9 out of that. So x equals the square root of 9 times the square root of 5. Which is 45 divided by 9 is 5. So x equals 3 times the square root of 5. Now time for the sponge. For all these problems, I want you to solve for x. So number 1, x is the geometric mean of 8 and 18. Solve for x. Number 2, x is here. Solve for x. Use geometric mean, of course. And third, here's x. Use geometric mean to solve for x. That's it for the lesson. Once again, please remember to take notes on the entire lesson. Attempt the sponge. Really, please do. Go back, rate yourself. Don't forget about that. Take a picture of your notes, submit it all to Google Classroom, and have a good night.